guys, welcome back again to another MATHNALO moment with me, Ma'am Coren. So for today's video lesson, we are going to talk about linear inequality in two variables. I guess you are familiar with linear inequality in one variable when you are in grade 7, but this time we'll be dealing with two variables. So actually, when we talk about this one, it is common to say that one side blank and the other side graph. So to understand further, let us have a thorough discussion of this topic. So when we talk about linear inequality, we have the different symbols greater than, less than, greater than or equal to, less than or equal to. So a linear inequality in x and y can be written in one of the following forms. It can be ax plus by is greater than c, ax plus by is less than c, ax plus by is greater than or equal to c, or ax plus by is less than or equal to c, where a, b, and c are real numbers and a and b are both not equal to 0. So again, it is important to note that a and b must not be equal to 0. So here are some examples of linear inequalities. We can have 3x minus y is greater than negative 2. We also have x is less than 2. We can also have x plus 3y is less than or equal to 0, and then y is greater than or equal to negative 3. As you would notice, for x is less than 2, the value of b is 0. While for y is greater than or equal to negative 3, the value of a is equal to 0. But a and b are not both 0 in one inequality. So for us to get the solution of linear inequality, it is actually similar to the solution of linear equation. So it is an ordered pair xy is a solution of an inequality in x and y if a true statement results when the variable in the inequality is replaced by the coordinates of the ordered pair. So we are going to substitute the coordinates of that ordered pair, and if the statement is true, therefore it is a solution of that linear inequality. So for the following examples, we are going to determine whether each ordered pair is a solution of 2x plus 3y is less than or equal to negative 6. So for the first example, we have negative 2, 1. Then we are going to determine if negative 2, 1 is a solution of 2x plus 3y is less than or equal to 6. So similar to what we did for the linear equation, we simply substitute the values of x and y given in our coordinates. So in this case, the value of x is negative 2. So we have 2 times negative 2 plus 3 times 1 is less than or equal to 6. Then we simplify. We have 2 times negative 2, correct? That is equal to negative 4. Then 3 times 1, yes, that is equal to 3. It's less than or equal to 6. What is negative 4 plus 3? Yes, negative 1 is less than or equal to 6. Is negative 1 really equal or less than or equal to 6? Correct. The statement is actually true. Therefore, negative 2, 1 is a solution. Solution of the linear inequality 2x plus 3y is less than or equal to negative 2, 6. Let us have another example. We have 1, 2. So again, we have the linear inequality 2x plus 3y is less than or equal to 6. So we have 2, replace or substitute 1 to x, and then we have to copy plus 3. We substitute 2 to y, is less than or equal to 6. And then simplify. 2 times 1, correct, that is 2. While 3 times 2 is actually equivalent to 6. It's less than or equal to 6. What is 2 plus 6? Yes, that is 8. So we have 8 is less than or equal to 6. Is the statement correct? Yes, the statement is false. 8 is actually greater than 6. So therefore, 1, 2 is not a solution of the linear inequality 2x plus 3y is less than or equal to 6. Let's have the last example for this solution of linear inequality. Let's have 3, negative 1. So again, we have the linear inequality 2x plus 3y is less than or equal to 6. So we substitute the values. So we have 2 times 3 plus 3 times negative 1 based from our coordinates is less than or equal to 6. Simplifying, we have 2 times 3, correct, that is 6. Then 3 times negative 1, yes, that will give us negative 3. Is less than or equal to 6. What is 6 minus 3? Yes, that is 3. So 3 is less than or equal to 6. Is the statement true or false? Yes, 3 is actually less than 6. So therefore, the statement is true. And we can say that 3, negative 1 is a solution of the linear inequality 2x plus 3y is less than or equal to 6. This time, we are going to graph our linear inequality. So the graph actually of linear inequality is not a line, but an area on the plane bounded by a line. So that is the main difference between linear inequality and linear equation. And actually, that is called a half plane. So a half plane consists of points which coordinates satisfy the inequality. So what do we mean? So in graphing a linear inequality, first, graph the related linear equation. So the knowledge in graphing linear equation is very crucial in graphing also our linear inequality. The related equation has an equal sign in place of the inequality symbol. So if the inequality symbol is less than or greater than, we are going to draw a solid line. But if the inequality symbol is less than or equal to or greater than or equal to, then we are going to draw a dashed line. Afterwards, we choose an ordered pair on one side of the boundary line or the line of the equation, and then test this ordered pair in the inequality. So the previous examples are needed in order for us to test in which side of the linear inequality are we going to shade. So if the ordered pair satisfies the inequality, then shade the region that contains it. If the ordered pair does not satisfy the inequality, then shade the region on the other side of the boundary line. So how are we going to determine the type of line to draw? Just like what I had mentioned a while ago, it depends upon our inequality symbol. So if we have less, greater than or less than, we are going to draw a dashed line. So that is a dashed line. And if the inequality symbol given is greater than or equal to or less than or equal to, we are going to draw a solid line. So similar to linear equation. So for the following examples, we are going to choose a type of line for the inequality given. Are you ready? So let us try. Given the linear inequality y is greater than or equal to 3x minus 2, what type of line are we going to draw? Correct. We are going to draw a solid line since the symbol that we use is greater than or equal to. How about this one? Y is less than 1/4 x plus 5. What type of line are we going to draw? Correct. We are going to draw a dashed line. And this is a dashed line. This time, you're going to choose the inequality symbol for the line shown. So this is the line shown. So are we going to have the less than or equal to, or greater than or equal to, or less than or greater than? Correct. We are going to choose the second pair. How about this one? Correct. We are going to have less than or equal to or greater than or equal to. I guess you are familiar in which type of line are you going to use in this linear inequality. So for the linear inequality, it is also important for us to determine which side are we going to shade. Commonly, if the given symbol is greater than or equal to, we are going to shade above the line. But if you are not convinced, you may use the solution of linear inequality to verify if the shaded part is actually the solution part of the graph. And then if we use less than or equal to, we are going to shade below the line. So this time, let us graph the linear inequality x plus 3y is less than 3. So if you can still remember, there are different ways in order for us to graph x plus 3y is equal to 3. We need to change first the linear inequality into linear equation in order for us to find points lying on that line. So if we have x plus y is equal to 3, we can have 3 points. So let us assume that if x is equal to 0, so if x is equal to 0, we have 0 plus y is equal to 3. So therefore, y is equal to 3. So we already have 1 point on this graph. So we have 0, 3. If we set y is equal to 0, so we have x plus 0 is actually equal to 3. So therefore, x is equal to 3, and our second point is 3, 0. Actually, if you can still remember, this is the y-intercept, and the second point is actually our x-intercept. Let us say that x is equal to 1. So for us to find the third point, to determine if they really falls on a same line. So therefore, we have 1 plus y is equal to 3. Since we have 1 on the left side, we are going to apply the APE. So we have y is equal to 3 minus 1. So to apply the APE, once again, we have to add the negative inverse from both sides of the equation. So we have 3 minus 1, which is 2. Correct. So therefore, our third point is 1, 2. Now we can graph the linear equation x plus y is equal to 3. So again, we are going to use our Cartesian coordinate plane, or simply our Cartesian plane. So this is a table of values that we already solved a while ago. We have 0, 3, 3, 0, and 1, 2. So let us plot the following points. So we have 0, 3. We also have 3, 0. Then we have 1, 2. Now we are going to connect that line similar to linear equation. But if you can still remember our discussion a while ago, it is important to note if we are going to use less than or equal to, or simply less than. Since this is less than, we are going to apply, correct, a dashed line. Now, since we already have a dashed line, we need to check if we are going to have the lower part or the part above the line. Actually, this is less than. So we are assuming that we are going to shade the part below the line. But for us to check, we are going to test. Usually we have 0, 0 or the origin. We are going to test 0, 0 if this is true. If this is true, we are going to shade the part containing 0, 0. So we have x plus y is less than 3. So therefore, we have 0 plus 0 is less than 3. What is 0 plus 0? Correct. That is 0 is less than 3. 0 less than 3? Correct. Since our statement for 0, 0 is true, which is 0 is less than 3, therefore, we are going to shade the region below the line. So this is now the graph of x plus y is less than 3. If you can still remember the line on our first slide, one side graph, the other side blank. So that is the meaning of the linear inequality, the graph of the linear inequality. Let us try some more. This time, let us have the graph of the linear inequality y plus 2x is greater than 4. So again, we have y plus 2x is greater than 4. Let us have if x is equal to 0 for us to graph this linear equation. So actually, we are going to change our greater than symbol into our equation. So we have x is equal to 0. We have x is equal to 0. We have y plus 2 times x, or 2 times 0 is equal to 4. 2 times 0, correct. That is actually equivalent to 0. So therefore, y is equal to 4. So our first coordinate of this equation is 0, 4. Let us have y is equal to 0. So therefore, we have 0 plus 2x is equal to 4. Since this is 0, we simply have 2x is equal to 4. To get the value of x, correct, we divide both sides of the equation by 2. So therefore, x is equal to, yes, 2. Since 4 divided by 2 will give us 2. Therefore, our x-intercept is 2, 0. To verify, let us have our third point. Say, for example, x is equal to 1. If x is equal to 1, we have y plus 2 times 1 is equal to 4. 2 times 1, correct, that is 2. So we have y plus 2 is equal to 4. By applying the APE, we have y is equal to 4 minus 2. And 4 minus 2 will give us, yes, 2. Therefore, our third point is 1, 2. Now we can graph our linear inequality in our Cartesian plane. So we have the points on our table of values. We have 0, 4, 2, 0, and 1. So let us plot the following points. We have 0, 4. We also have 2, 0. And we have 1, 2. So we are going to connect that one or the 3 points. Are we going to use a dashed line or a solid line? Correct. We are going to use a solid line since the symbol for this linear inequality is greater than or equal to. Now, let us have the points or the part that we are going to shade. So again, for easier solution or easier way, we are going to have 0, 0 as our testing point. So we have 0, 0. So we have the linear inequality y plus 2x is greater than or equal to 4. So we have 0 plus 2 times 0 is greater than or equal to 4. Yes, we have 0. 2 times 0, correct. This is 0. It's greater than 4. What is 0 plus 0? Yes, 0 is greater than 4. Is the statement true or false? Correct. The statement is false. Since on 0, 0, our statement is false, we are going to graph or we are going to shade the opposite side of that line. So we are not going to shade the part which contains 0, 0, but the other side of the line, which is actually above the line. So this is the graph of the linear inequality y plus 2x is greater than or equal to 4. This time we are going to graph the linear inequality 2 over 5x plus 3. So we can graph linear equation by applying the slope and the y-intercept. So we are going to use that one on this example. So the y-intercept here is 3. So we are going to plot 3 in the y-axis. And then if you can still remember, 2 over 5 actually stands for our slope. And slope is simply the rise over the run. So our rise is 2 and our run is 5. They are both positive. So therefore, we are going to have 2 units upward and 5 units to the right. So again, we have 2 units upward, 1, 2, and then 5 units to the right, 1, 2, 3, 4, and then 5. So that is our second point. And this 2 over 5 is actually equivalent to negative 2 over negative 5. So meaning we are going to move 2 units downward and then 2 units to the left. So we have 2 units downward, 1, 2, 5 units to the left, 1, 2, 3, 4, then 5. So that is our third point. So now we are going to connect the 3 points. But we have the linear inequality symbol greater than. So what type of line are we going to draw? Correct. We're going to draw a dashed line. Again, we are going to check which side are we going to graph. So let us have or use 0, 0 once again for us to easily check. So we have y, or this is actually equivalent to 0. So we have y is greater than 2 over 5, x plus 3. So we have the value of y, which is 0, over is greater than 2 over 5 times 0 plus 3. 2 over 5 times 0, correct, that will give us 0. And what is 0 plus 3? Correct, that is 3. Is 0 greater than 3? Is the statement true or false? Correct. The statement is actually false. So therefore, we are going to graph or we are going to shade the line, the part that do not contain 0, 0, which is actually above the line. So there you have it. This is the graph of the linear inequality y is greater than 2 over 5x plus 3. So this ends our discussion about linear inequality in two variables. I hope and I wish that you have a MATHNALO with me, Ma'am Coren. So see you again in our next video and thank you for watching. Goodbye and God bless.